Previously, I asked you to complete question 5A on your own. This is looking at two solutions in a precipitation reaction. And in the question, one of the things that you had to determine was the identity of the precipitate. So in the reaction, we had 2 moles of sodium phosphate that reacted with 3 moles of calcium chloride to form 6 moles of sodium chloride and 1 mole of calcium phosphate, which is our precipitate in this reaction. We used solutions with a molarity concentration given and a volume given in order to get to moles for our two starting materials. We looked at our stoichiometric calculations. And in those stoichiometric calculations, we determined that it was the sodium phosphate that was our limiting reagent, giving us a theoretical yield of 0.0580 moles of calcium phosphate. That also means that it was the calcium chloride that was our reagent in excess. And as we move on to 5B, this is going to be a key piece of information for us. In order to wrap up 5A, when we converted our calcium phosphate theoretical yield to grams, we got a total of 18 grams as our theoretical yield, giving us an overall percent yield of 81.7%. So, as we take this information and move on to 5B, the first thing that's going to be really important for us to recognize is that the sodium phosphate was our limiting reagent. That means that it was completely consumed during the course of the reaction. None of it is left over. The calcium chloride was our reagent in excess. That means that some of it reacted in the reaction and some of it's left over at the end. In question 5B, we need to calculate how much of that calcium chloride is left over at the end of the reaction. In order to do this, one of the pieces of information we need to know is the fact that we had 0.216 moles of calcium chloride at the start of this reaction. The next thing we need to know is the stoichiometric relationship between our two starting materials. We know that all of our sodium phosphate reacted. We also know that for every 2 moles of sodium phosphate that reacted, 3 moles of calcium chloride will react. We are going to use that stoichiometric ratio in order to determine how much calcium chloride is left over at the end of this reaction in 5B.
Now in question 5B, we're asked to calculate the mass of the reagent in excess that would be left at the end of the reaction. So in 5A, we learned that the sodium phosphate was our limiting reagent and that the calcium chloride was our reagent in excess. So based on that information, we know that the sodium phosphate is going to be completely consumed and so in this question, we're looking to find out how much calcium chloride is going to be left over at the end of the reaction. What we know from the balanced chemical equation is that for every 2 moles of sodium phosphate that reacts, 3 moles of calcium chloride reacted. So based on that, because our sodium phosphate was our limiting reagent, we know how much of that reacted during the course of the reaction. What we're looking for is how much calcium chloride reacted. In our calculations from part A, we know that we had 0.116 moles of sodium phosphate at the beginning of the reaction. And because that's the limiting reagent, all of that was consumed. We also know from the information in part A that we had 0.216 moles of calcium chloride at the beginning of the reaction. So what we can do is we can look at a stoichiometric calculation between our two starting materials. We have 0.116 moles of sodium phosphate. We know that that completely reacted. So when we convert from moles of sodium phosphate to moles of calcium chloride, we're going to use the coefficients in the balanced chemical equation. So that means calcium chloride has a coefficient of 3, sodium phosphate has a coefficient of 2, so that's going to give me a 3/2 mole ratio. So now what I know from this calculation is that 0.174 moles of calcium chloride reacted. I know that I had 0.216 moles of calcium chloride to start. So if I subtract these two values, that's going to tell me how much was left over. So I'm going to take my 0.216 moles from the start of the reaction minus my 0.174 moles that reacted. And so I know that I have 0.042 moles of calcium chloride that's left over. The last thing I need to do in order to answer this question is to convert to grams. So 0.042 moles of calcium chloride. I'm going to multiply by my molar mass. 1 mole of calcium chloride has a mass of 110.98 grams. And so from that information, I know that 4.7 grams of calcium chloride is left over in the reaction.